All right, guys, I got me a new meter. I needed to get something a little jazzier and specific, one that does inductance and capacitance as well as resistance. So this meter is an LCR meter, inductance, capacitance, resistance, and this is a Camway LCR meter. I got this off of Amazon. I don't remember the exact cost. I'll post a link to it in the description below. This is a model TL34. If you look for LCR meters on Amazon or any electronics supply site, there are a bunch of them. This has a very nice large LCD display. I don't even have batteries in it yet. I've got to get a screwdriver and pop the cover. So I'm going to do that and get batteries in it, and then I've got some components we can hook up and take a look at. Be right back. Okay guys, so here's the meter. This is the BM4070 from Camway. That's how it's listed on Amazon, a Camway LCR meter. And I will put a link below in the description to this on Amazon. So this meter has, here's our ranges. This meter does inductance, capacitance, and resistance, and it will also test the forward voltage drop on a diode. The inductance range is obviously 0 microhenries up to 20 henries of inductance. The resolution and accuracy changes based on the range. You can see that here. I'm not going to read the whole entire chart because I don't want to put you to sleep. Same with the resistance, 0 ohms up to the 20 megohm range. Again, with our tolerance and our resolution of measurement for each range on the resistance. Our capacitance range is over here, and it's from 0 picofarads up to 2000 microfarads of capacitance, again with tolerance and resolution out here on the side. The meter comes with 2 test leads and also the ability to just slide a component in a slot and test it that way, again as long as you pay attention to the polarity of the component you're testing. Some components have polarity, some don't. Capacitors, depending on the style of capacitor, some are polarity sensitive and some are not. The display, let me turn this on, as you can see is fairly large, which I like because I'm a, ooh, you can't see that on the camera, it's a lot of glare. Let me turn it back on. It's a nice big display, which is really easy to see. I'll have to hold this while I do this because you won't be able to see it on the camera otherwise. Anyway, so it gives you instructions, basic instructions about how to use it for the different measurements. And safety tips: don't use this in the bathtub or while juggling chainsaws. Very important safety tips. Don't lick the shiny metal parts. So this meter will test capacitance, resistance, and inductance. I have 2 or 3 components here that we can take a look at. I don't have a diode handy. I have some LED diodes, but I'd have to go dig them out of a box, and I'm entirely too lazy for that. So what we're going to do is take a look at these components. So the first thing I want to look at is this toroid over here. This is a QRP guy's end-fed half-wave antenna I put together. It's a small kit, not much to it. The hardest part was winding the toroid, slapping on a small capacitor, soldering down, you know, the connectors. Okay, so we're going to test our little antenna here and check the inductance that we're getting across the leads of the toroid. So the scale is on 2 millihenries. We're reading 0.288 millihenries or 288 microhenries. All right, across this toroid. And that sounds like a reasonable value. So there is our inductance test. Now on our capacitors, the rating on these guys, this is a 470 microfarad, and these style capacitors have polarity. So we want to hook up the the black lead to the negative post. The other thing about doing capacitors, and I discharged these before off camera, and I knew these were discharged because they're in a bag. These are brand new, never been used. If you're testing capacitors that you just pulled out of a circuit or that are in circuit, you need to make sure you discharge them safely before you hook them up to your meter, or you may let the smoke out. So we're going to hook this up to the negative lead, positive to positive. And as you can see on the scale here, I'm reading a 1. It's not picking it up because the the value of this is bigger than the range on the meter. Let me see if I can, oh, if I scoot that down, you can read it. Oops, it was shorted together there. So we're still not picking it up at 200. If I go to the 2000 microfarad range, we get 395 microfarads on this particular capacitor. And I don't know the tolerance on these. This is green. That may be a lower tolerance. And then I have another capacitor here. This is a 33 microfarad, and it's a blue one. And again, it has polarity. So we'll hook up to this one. And we're reading 34 microfarads. Now I can scoot the scale down to the 200 microfarad scale, and we're reading 33, which is well within tolerance on this guy. That's 1%, give or take. So I'd say the meter is pretty accurate. This component may be dodgy, and I have another one of those handy, so let's just do that for giggles and see if we get the same values. Maybe green means not very good. Apparently that's just a sketchy component. That's a much better value, 423 microfarads on this guy. So these are obviously not high quality components. This is rated at 470. And that's a heck of a tolerance between these two, 394 and 423. So, but dead on the blue one. So I'm going to guess that there's a difference in tolerance between blue and green capacitors. All right, our resistance. The meter also checks resistance. This is a 51, yeah, 51K. Resistors don't have polarity, so we could just hook these up. And we're getting 50.6, which is, again, well within tolerance. So I would say that the meter seems to be working pretty well at this point. The meter has a data hold function, which I haven't set up. If you take your readings, you can hit data hold and it stores them in a memory for that function. It also has a zero adjust, which I didn't see any issue with. I didn't mess with this at all, and this may be the zero, the zero adjust may be the difference on our capacitor ratings, although the 33 cap read just fine, so I don't think that's it at all. As I mentioned, you can stick components directly in there, but you got to pay attention to positive and negative for your components so you don't have to hook up leads. I think if there was one thing I don't like about this particular meter is that it came with alligator clip probes, and I would much rather have the little hook kind that will stick on a lot better than something like alligator clips. All right. So that's the meter. I bought this because I'm planning on doing some bandpass filter work. That's something I want to get into. I have a specific function I want to do. I mentioned in a previous video yesterday, I believe, that I use an ADS-B Pi software and an ADS-B antenna for aircraft tracking software. And one of the things you can do with that is put a bandpass filter on it to tweak out, to squeeze out all the extraneous noise and just tune in on the 1090 megahertz band that ADS-B transmits on. So it'll give you a better signal. It's a filter. That's what it is, a bandpass filter. And to do that, I'm going to need to fool with capacitance, resistance, and inductance. So that was one of the reasons I got this meter. Anyway, that's my project. This meter was about $30, $35 on Amazon, maybe a little more, a little less, somewhere in that neighborhood. And this is, again, this is a Camway LCR meter. And they call it a Model TL344. This says SZBJ BM4070, so, you know, your mileage may vary, with a completely unrelated serial number on it. The screen also tilts up, which is nice. Now with an overhead camera, that didn't really help us a whole lot. But that's a pretty cool feature, I thought. And that just locks in place unless you hit the orange button. So if you were sitting at a bench, right, I can sit here on at my bench and see the meter without having to stack the meter up. The meter does not have a bail to stand. So that's the only way you're going to be able to elevate the screen. And that actually, I think, is better than a bail for the entire meter. So anyway, that's what I've got. I just wanted to do a quick little review of it. Guys, if you have any comments, I would love to know if there is a difference between green and blue capacitors. I kind of assume there is in tolerances similar to resistors, but I don't know that off the top of my head. And I could Google it, I just haven't looked it up. Feel free to comment if you have anything. Guys, if you would give me a thumbs up, make sure you're subscribed to the channel, and make sure and ring the bell so you get notified whenever I post new content. That's all I've got for now. 73, y'all. Have a good day.